could find 1 radian is if the angle at the arc was the same as radius. That's what a radian is, and it's inverted. Today we're going to look at actually like solving some problems using formulas that use radians in them. And so one of them is arc length, right? Arc length is the length of this arc. It's hard to measure that because it's curved. So in my lovely picture here, I have the radius, right? Either one of these sides could be the radius. The circle is the same all the way around. And then this is my angle measure. You can use whatever you want for angle measures, but most of the time they use a Greek letter. Lots of different Greek letters, but probably just like in algebra, our go-to letter is X. In trig, our go-to Greek letter for angles is theta. Kind of just like a circle with a line in it. It just means a variable. We don't know what it is. You'll see in your book they say that a lot, but it's always a Greek letter. I don't know why we do Greek letters. Outside of math class, fraternities and sororities use Greek letters, and so someday maybe in college you'll join a fraternity or sorority with theta in it, and you'll have fun memory. Or maybe that's you won't join that one that has theta in it just because of my favorite Greek letter is mu. There's a shirt you can buy. I haven't bought it yet, but I find it very funny. It has a cow on it with a little thought bubble, and it has this symbol on it. So unless you know the Greek letter, you don't think it's funny because it says mu. My favorite Greek letter. I don't know a lot of Greek letters, but I got mu, I got theta, I got alpha, I got beta. That's not it. But I did print off. I have a whole list over there because sometimes people ask me about Greek letters because they think because I know trig I should know them all, but there's capital and lowercase, and I don't know them. But theta is our go-to, right? Just like what am I supposed to write here? Theta equals S. So if you want to solve for the angle, and you know the arc length, and you know the radius, then this is your formula. I wrote this out in words here for you. This equation is in words here. The angle in radians. So really important. If you do this with degrees, you're going to get the wrong answer. So you have to make sure you're in radians is equal to the arc length divided by the radius, which means this is an equation. We could solve for R or we could solve for S. A lot of times we're looking for the arc length, right? It's easy to tell the radius of a circle. It's easy to measure an angle of a circle. It's hard to measure this. And so solving for S here, I would just multiply R over, so S is the same as R times theta, right? Those are the same equation, just solving differently. On your homework today, I'm going to make you solve for all three. So depending on what you're looking for, what one thing you can solve for. So that's our arc length. So notice on number 1, it says find the arc length if theta is 5 pi fourths and the radius is 20 millimeters. You can draw a picture if you want, but we don't really need to. 20 millimeters isn't that much of a radius. 5 pi fourths, just kind of to start thinking about in terms of radians. Remember that 180 degrees is pi radians. So 5 pi fourths, is that more than 180 or less than 180? Is that... From here to here is 180 degrees, aka pi. Yes? So I want you to start thinking about radians without converting every time. So what I don't want you to do, I don't want you to see a radian, and if I ask you what it is, like how big it is, I don't want you to like, let me compute it into degrees, and then I'll tell you. I want you to think about fractions. 5 pi fourths. Is that bigger than pi, or is that smaller than pi? Bigger, because 5 pi fourths is 1 and 1/4. Right? So you can think about how big is 5 pi fourths. Oh, well, this is pi. And then if I went 1/4 more, oh, that's going to be down here somewhere. And that's what I want you to kind of start thinking about as we go forward with radians. I do it every time. Just kind of think about what that is without doing that. But for us, all we have to do is use the formula. S equals R. our radius is 20, and our theta in radians, 3 radians, is 5 pi, of course. This works out to be 25 pi. And again, it's up to you. I'm going to leave my answer as 25 pi, because that seems like a good answer. If you want to multiply by pi, you can actually see, like, how long is that? We're talking about the length of that circle. So this would also be in millimeters. If you put 25 times pi, that would be the same as about 78.5 millimeters. So that's like over half of the circle there. Kind of like a chunk of the circumference. Why I just think you want to do 3, because you can do 3, because you have to change it first, right? Alright. But on this one's a really big circle, right? The radius is 12 feet. 7 pi fourths. Is 7 pi fourths bigger than pi? Yes. Is 7 pi fourths bigger than 5 pi fourths? Yes. 7 pi fourths is almost 2 pi, right? 8 pi fourths would be 2 pi, so that means we're almost back all the way around the circle. So again, it's really easy if it's in radians. You just multiply the theta times the radius, and so this one would be 21 pi. But you might say, hey, that's smaller than the last one, but remember that we're in feet now, right? Did I do that right? 65.97. Again, I'm okay if you just do that. If it was in degrees first, you have to change it to radians, right? Like you can do that all at once. If you want to add that, if you want me to throw another question in here. If I said theta equals 40 degrees and the radius equals 3 inches, you cannot just take 40 times 3. You have the wrong answer because the formula only works in radians. All of our formulas today only work in radians. So you can do it all at once. Like if I was doing this, I would say, well, my R is 40, and I'm going to convert that to radians. So I'm going to multiply by pi over 180. Right? So that becomes my my theta. And then I'm just going to multiply by R again, which is 3. So just don't forget. On the test, I put a question like this. Probably over half the people always miss it because they just take R times theta and they don't change it to radians first. That works out better, right? 2 pi thirds. That's true. Did you get that? That's 40 times 3 is 120, and 120 over 180 reduces to 2/3 pi. And again, if you'd rather multiply it out, I think that's like 2.09. So just don't forget that. Alright, we can also talk about motion in a circle. Technically it's called rotary motion, but if we're talking about like tires spinning or Ferris wheel spinning, other things that are circular spinning. One of the things we can talk about is angular velocity, angular speed. We're talking about the angle changing per unit of time. What's the difference between velocity and speed? I kind of use it interchangeably here, but you know the difference? Speed is always positive, right? So speed always is a positive number. Velocity can be negative if something's falling, right? It has a negative velocity, so like if I dropped this guy, the rate that it was falling, if I'm talking about velocity, would be negative. If I threw it up, the rate that it was going up would be positive velocity. So velocity has direction. Speed doesn't. Speed is just always not fast. So we kind of use those interchangeably, but just here's another lovely Greek letter for you. It kind of just looks like a W, but it's really omega. I don't know what it is. So the formula for angular speed or angular velocity is, that's the symbol that we're using, omega, and it just equals theta, the angular displacement, over time. And time is whatever units it asks us to find. So time can be whatever units they tell us, but theta we got to have in radians again. All right, so it's kind of a lot of and so it says find the angular velocity, and they tell you what units they want it in radians per second. So that means you have to get your units in radians per second for a wheel making 2/3 of a revolution in 3 minutes. That's a really slow moving wheel, right? Ever been on one of those really big Ferris wheels that's just like creeps along? That's what I imagine for this. 2/3 of a revolution in 3 minutes. So they kind of give us an angular velocity right now in the wrong units. They tell us, I'm going to do this omega W. I'm going to say right now, we know that it's 2/3 of a revolution in 3 minutes. All we have to do is convert those from revolutions to radians and from minutes to seconds. The minutes to seconds part's easy, right? How can I convert 3 minutes into seconds? Yeah. There in 1 minute there's 60 seconds. You could just say 3 minutes is 60 plus 60 plus 60, and you could just change it. Or you could do in there are 60 seconds in 1 minute. Right? So 3 times 60 is the same as 160. Is that true? Yesterday we did a lot of converting from degrees to radians, radians to degrees. We don't talk about revolutions that much. We did at the very beginning. How many radians are in one full revolution of a circle? 2 pi, right? There's 360 degrees, which is 2 pi radians. So if we're converting revolutions to radians, we can just use that conversion factor that there are 2 pi radians in one revolution, right? So 2/3 of a revolution, I can just multiply by 2 pi. Again, I'm going to put my units here so you can kind of see what's happening here. But 2 pi radians is one revolution. Those revolutions cancel out. And I would just get 4 pi thirds. Questions on where I got that from? So now I have 4 pi thirds radians in 180 seconds. You think I want to leave your answer like that? No. We don't leave fractions in a fraction, right? We're going to simplify this so it looks better. And if I divide by 180, right, isn't that the same as just multiplying 4 pi thirds divided by 180 is the same as multiplying by 1 over 180? Right, so this is like 180 over 1, so I can multiply by the reciprocal. So 4 goes into 180 45 times. So we get pi over 1/35, and that's in our correct units. That's in radians per second. That's kind of hard to visualize because it's kind of hard for me to visualize radians. But pi 1/35 is pretty small, right? Pi is 180 degrees. Pi halves is 90 degrees. what we said, pi thirds is 60 degrees, so think pi 1/35 is super, super tiny. That kind of makes sense that it's not going very much every second if it takes it 3 minutes to not even go all the way around the whole circle. And so, kind of hard to visualize, but you can at least see if it makes sense. If we would have got something bigger than pi here, that wouldn't have made sense, because there's no way it's going 180 degrees every second. That'd be very fast. But, kind of hard when it's in radians. And so the next one I think is more useful. So I got one more formula for you. And I kind of go a long way here to get you to the formula to show you where it comes from in case you ever forget it, but there's really just one formula. So we have angular velocity, which tells you like in radians per second. Easier to visualize is in linear velocity, which is going to give you it in like feet per second, and that's a lot easier for us to visualize. Or whatever. So, let's use V here, it's not a letter. It says V is a point on a revolving ray, is the linear distance traveled per unit of time. And so, it says V equals S over T. S is the same S that we used on the very first slide, which is arc length. S is arc length. And if you remember, our formula for arc length was S equals R times theta. So unless you already computed S, you have to just know that that's really R times theta over time. And so instead of writing it as S over T, I think of it as R times theta. And then, changing it to talking about angular speed, you just found angular speed was theta over time. See how we have a theta over time over here? So we could say that this is R separated as theta over time. And that's the same as just R times omega. Why did I write it 17 ways? I don't know. To me, this is probably the one I use the most because usually I know the radius, I can find theta and the time. Sometimes they ask you to find the angular speed, and then the very next part says find the linear speed. So if you know that, if you found the angular speed already, all you have to do to find the linear speed is multiply by the radius. And so that's why I think that this one's kind of nice as well to remember if you found that already. You don't have to memorize all those, but you do need to know one of those by the time that we have a test in here when we do that. Calculate the linear velocity in feet per minute of a person on the rim of a Ferris wheel, because this only works if you're on the Ferris wheel. 208 feet in diameter that takes 20 seconds to rotate once, and I feel like this is a very dangerous Ferris wheel that goes around in 3 seconds. It's very, very worrisome. I always tell the story when I do this question of I threw up on a Ferris wheel once, which is very embarrassing. I was pretty old, like in my teens, threw up on the Ferris wheel because I went on this terrible ride before then that spun me all around and made me all dizzy. And then I was with my grandma at this fair. And I was like, oh, Grandma, I don't feel good. I'm going to throw up. I just want to go lay in the car, and you guys stay at the fair. And she's like, no, you'll be fine. Drink some Sprite. Go on the Ferris wheel. It'll calm down your stomach. And I believed her. And I was there with a boy that I was dating. And we go on the Ferris wheel together. And every time, you never know this until you're about to throw up. But every time you go on the top of the Ferris wheel, like every time you go over, there's this moment that like it makes the throw up come up even more. And so every time we went around, I was like, oh my God, I'm going to throw up. But I didn't. And then we're waiting. Like, we're at the top, and we're just waiting to get to the point to get off the Ferris wheel. And I was like, I'm not going to make it. I'm not going to make it. And so I just lean forward and, like, make the whole seat go forward and, like, throw up all over the ground. And I got off the Ferris wheel, and I was like, I'm going to do it. And I maybe threw up behind the fly on the way to the front. The bag down. Yeah. That's embarrassing. So anyway, every time I read this question, I think I would throw up on this Ferris wheel. It goes too fast. If you know the formula, it's all about making sure you have the right thing on there. So When they ask me for the radius, we're not going to put 208 in there, right? That would trick you. What are you going to put in there? Because the diameter for the radius is half of that. So that's going to be 104 feet. So that I can, and that's nice because they want it in feet per minute, which means I don't have to convert if they gave it to me in another unit. And then theta has to be in radians. And so again, they tell me that it's 20 seconds to rotate once. So that means we're going all the way around. So how many radians is going all the way around? 2 pi. So for theta, I'm going to put 2 pi in there. And then for time, it wants it in minutes, and it tells me it only takes 20 seconds to go around there. So again, either you can just know that conversion in your head, and you can know how much of a minute is 20 seconds, or you can always do the conversion. In 1 minute, there are 60 seconds. So 20 seconds is just 1/3 of a minute, right? But that's where the conversions are very nice if you struggle doing that or knowing that. Multiply by what you know it is, and then that's just 1/3. I feel like the Ferris wheel, it would not get approved for the safety commission. Is there a safety commission for Ferris wheels? I feel like at fairs, there's no safety commission. So I'd have 208 divided by 1/3, which is really the same as just multiplying by 3. Right, divided by 1/3. So that's 624 pi feet per minute. I'm going to multiply by pi just so you can get an idea of how fast this is. Got to change this to miles per hour so I can see how fast this Ferris wheel is going. Right? Is that true? .624 pi is 1,960.35 feet per minute. It asks for feet per minute, so that would be your answer. Right, 5,280 feet and 1 mile. Not so bad, right? It's only 22 miles per hour. Is that too fast for a Ferris wheel? 22 miles per hour. Questions about that? And so again, to me, linear velocity is something that's more applicable outside of this class. In physics, which I know not everyone does physics, doesn't plan to do physics, but in physics, they're doing this. They did linear velocity, they did angular velocity, because some of the kids told me yesterday, are we going to do this? Because we didn't really understand it when we did it before. I said, yeah, we're going to do that tomorrow. So, we'll see. All right, I got one more question. Find the perimeter of a 30-degree slice, because, you know, when you get your pizza, you always measure what the slice is, of a large 8-inch radius pizza. I'm going to go. Okay. Keep it strong. If I'm talking about the perimeter of the pizza, what am I talking about? Of the pizza slice. Anyone? Perimeter? Hello? All the way around. So if a pizza slice, all the way around, is going to be this part, plus the curved part. It's an 8-inch radius pizza, so where does that go on my pizza slice? It's 8 inches. It's 8 inches. The sides, right? Because hopefully from the center to the edge, it's going to be the radius. So hopefully they cut it there. So this is 8 inches, And this is also 8 inches. That's 16 inches of the perimeter right now. Let's want to find that part. What's that part called in our math speak that we learned today? What? Yes, it's the arc length. So we have this lovely formula that S equals R times theta. So it's nice that they tell us that it's a 30-degree pizza slice. So that would be, do I just take 30 times 8? No, because I have to do it in radians, right? So I'm going to take 30 times pi over 80 times 8. And that's going to be my 6 times 8 is going to be 4 pi thirds. I'm tired. 6 times 8 divided by 2. So if I add all that up, my perimeter of my pizza is 8 plus 8, which is 16, plus 4 pi thirds. You can't add something with pi in it to something without pi in it if you're leaving this as an exact answer, which means you could say 16 plus 4 pi thirds of an inch. Or if you want to add up, you have to just get decimal. Some people like to think they can get a common denominator there and just put pi in both of them, but that's not true. If you wanted to get a decimal there, that's about 20.2 inches is the perimeter. Alright, so again, another application of am I using arc length, am I finding linear velocity, am I finding angular velocity? Questions about that? Alright. Alright, so this is 4.1 day 2. I really have a goal of getting you an assignment sheet tomorrow. I have them ready, I just haven't copied them. Only 5 questions. I'm going to keep it around. Time to work, so please look on this. There's a linear velocity on the end. You should be able to do that question. 25% of here are just arc length questions. And then 36 for floor problem, and 56 is the angular speed. So